Welcome to Toll 101, Introduction to Tolling, Toll Principles and Practices. This program is made possible through funding provided by Aegis Projects, Inc., and with the additional cooperation of Atkins, Valencia College in Orlando, Florida, and Patterson-Bach Communications. Hello, I'm Marty Stone, Chief Operating Officer of Aegis Projects USA, a division of Aegis Group, and I'm joined today by Tom Nucky, National Toll Technology Director from Atkins, a member of the SNC Lavalin Group. Toll 101 was designed to educate a variety of audiences to the unique characteristics and value of tolling as part of the approach to finance, build, and operate viable transportation solutions in North America.
Today, most funding for highway maintenance and expansion comes from state and federal gas taxes. These funds have run low and are expected to continue to diminish, primarily because cars have become more fuel efficient. Though some states have increased their gas taxes, the federal tax on gasoline hasn't changed since 1993. Federal taxes go into a fund dedicated to transportation called the Highway Trust Fund. Since 2008, this fund has gone into the red. It's up to Congress to figure out what to do about the federal trust fund. But states have similar trust funds with the same problems. We believe tolling is a very important part of the overall solution of the surface transportation problems facing virtually every urban area in North America.
Toll 101 is divided into 7 segments that are introductory in nature. They're not designed for experts or to make you an expert. They should be perfect for those interested in a high-level view of the toll industry, how tolling works, the different approaches to toll technology and operations, things that would give someone a good basic understanding of the toll business.
This series will be ideal for engineering and planning students or new hires for toll and transportation agencies, or for the companies that support these types of public agencies. This education would also be beneficial for elected and appointed public officials who are involved in transportation.
So you can watch this series sequentially, or you can watch each section individually, depending upon your interests. Again, thank you to Tom Nucky from Atkins for helping me present Toll 101. And I hope you find this material helpful in better understanding tolling and transportation in North America. Hello, and welcome to Section 5 of Toll 101. This is an overview of transportation planning. When you look at the activities related to transportation planning, you may ask, why is transportation planning a part of a toll presentation? And that's primarily because a good toll road first has to be a good transportation project. If congestion is high enough to create the demand for a new surface highway, then it has a very good chance of creating a good toll project. But if the demand is not there, if congestion does not exist in a community, and there is no reason for widening of an existing highway or building a new highway, then you probably do not have the rationale for building a toll road. So this is about the transportation planning process and how we develop ideas, the planning, the design, and eventually move forward into the development of a new project that first has to be a good transportation project, and then it will be looked at in terms of the feasibility, the financial feasibility, as being a good toll road. It really begins back where we started. Tom, if you remember, we started our very first discussion and overview of the toll business. We talked about the federal-state partnership. This is one of the critical elements in terms of transportation planning, this relationship between the federal government, state governments, and local governments, and how they work together in the planning and design and delivery of projects. It begins at the federal level, and it involves these 3 organizations: US DOT, the Federal Highway Administration, and the Federal Transit Administration. And the key element related to the federal side of the federal-state partnership is that these organizations do not plan, do not deliver, do not construct projects. They develop funding for projects, and that funding usually comes through, again, a congressional formula. And they develop standards, federal standards, for what projects will look like and how they must be planned if there are federal funds involved. And some toll roads do involve the use of federal dollars. So standards, requirements, and a certain amount of oversight comes from the federal government. But again, the key element is that the feds do not deliver the actual project. The projects themselves are delivered by the state. The responsibility for planning, design, development, funding, ultimately the specific projects are really done at the state level. And this responsibility at the state level can be handed down through state law to various regions and local governments within the state. But in the federal-state partnership, the responsibility for the delivery of projects really rests at the state level. And again, these are projects that are funded with either federal dollars or state dollars. Certainly, local communities who are expending their own funds will have the responsibility for planning, designing, and delivering local projects, but they usually have to do so within some outline presented by state law, the state that they're within. So we're going to take a look at the planning process for all of these players, and there are quite a few of them in the federal-state partnership.
There are, Marty. It's almost like a concert and an orchestra and a conductor, and usually the conductor is the one leading the concert. But in order for it to work, there has to be a lot of players doing their parts. And so, you know, we typically see the state government, usually the DOTs or the statewide toll organizations, often in the lead on these projects, following the rules that are created by that state and the federal rules, as you mentioned. But then these projects don't work without the participation of many other entities, and their roles vary by what their jurisdiction is. So we see metropolitan planning organizations, which are tend to be around large metro areas, very involved in these because they have often long-range plans for their transportation needs, and through working through them, we can better identify corridors and needs as well. And then we see small cities and counties that have roles in sometimes the approval process, but oftentimes in the contribution to the ideas and the planning side, because they have their own planning entities and need to participate in these planning efforts for toll facilities. And then we also see the local transit agencies. They may need bus rapid transit or express bus corridors, and then again, these can be incorporated in the transportation planning process. And then that wraps also into the local regional mobility authorities that may be given a plan or may have worked on a plan that needs to be coordinated with these other jurisdictions. So it's a large team effort and many players involved with many different roles depending on their authority.
So, Tom, no matter which one of these entities are involved, and no matter what their tasks, no matter what their laws say, who gets to do what, they all follow a very similar transportation planning process. And if you look across the U.S. At the various states, at the federal government, and even at most local governments, you'll see that transportation planning is broken down into three main pieces: system planning, program planning, and then project planning. When we talk about system planning, we're really talking about the coordination that occurs at a very high level between those people who are planning land use and those people who are planning the transportation. And this symbiotic relationship between land use and transportation continues throughout the entire transportation planning process. System planning is also about setting high-level resource allocation. It's when you're looking at how much revenue is coming in, And cities and counties and states go through this process regularly, sometimes on a 5-year basis. And that's really the short-term elements. And then on a long-term basis, they look out generally as long as 20 years in looking at their resource allocation. In essence, they have to try to project where their revenues are coming from, where they're going to be spent over fairly long periods of time. And the reason it is such a long period of time is that it takes a long time to plan and develop and design and eventually construct transportation. And transportation are usually very expensive projects. So we're not out there doing this every day. We're not out building a new road every day. So these are very long-term projects, and that's why the resource allocation tends to be between the 5 and 20-year time frames. When we look at program planning, that takes this large 5 to 20-year time frame and starts bringing it down into various components. There are programs for special needs. There are energy conservation programs. Air quality becomes one of those programs that, while it certainly affects transportation, goes well beyond just transportation. And then when it comes to alternative transportation modes, sidewalks, trails, bike paths, all of those components have their own programs within the larger transportation planning process. But when we look at those, what we see are ancillary components to the planning and siting and ultimate development of large toll projects. And then there's project planning, and that's generally broken down into 2 pieces. You either have major projects or minor projects, and minor improvements are things like intersection improvements, safety activities, traffic signals, the striping of highways, and very often those are maintenance kind of projects that are wrapped into a minor improvement project. Typically, these are done on toll roads, but they are not the focus of transportation planning. It's the major projects, the development of new transportation corridors, the widening of major highways, and certainly the design, development, and building of new toll roads that fall in that major project category. And that's really what we're going to focus on in today's discussion. So it's the system, program, and project planning for major projects that we're going to look at. And you mentioned the MPO. Sometimes it's referred to as an MTPO, the Metropolitan Transportation Planning Organization. Sometimes it's vested in an organization called a Council of Government, a COG. But whatever the terminology, there's usually an overarching organization that brings in multiple municipalities and jurisdictions into the transportation planning process. And the result or the product of long-range planning is called an LRTP, a long-range transportation plan. And generally that is a long-range plan and a system forecast that goes out a minimum of 20 years. Now, some agencies have started to look beyond 20 years because it sometimes takes somewhere between 10 and 15 years from the beginning of planning all the way through construction of a major project. We found that the 20-year horizon may not be necessarily the best to use for a major project. Toll roads tend to go a little faster because toll road planning tends to come off of an existing planning process. So when toll roads get involved, it's usually after this long-range transportation planning process has begun. So we're starting to see MPOs look out 30 years and even 40 years sometimes in looking forward to determine what the needs are within a large urban area. This process includes a system analysis. That system analysis is broken down into 3 pieces. And we're going to take a quick look at those pieces. The first one is identified as the deficient roads or needs plan. And what you're looking at on the screen is a graphic that is very similar to what most MPOs use when they define what their needs are. And essentially they use a large computer model based on a graphic that looks a whole lot like the GPS program in your car, right? And in fact, the models that we use in transportation were the forerunners of what you have in your car and what you use on Waze these days. These computer models it's what we've been using in transportation for the last 35 to 40 years to do our long-range transportation planning. So the first activity is to look at a needs plan. And you do that by doing traffic counts out on roads. You probably have run over lots of tubes that you've seen out in the roadway. Today we've gotten a little more sophisticated. Most of our major roads have loops embedded in the road that give us accurate traffic counts 24/7 on roadways. So we know how much traffic is on these roads, and we know that based on the design of the road, how much traffic that road should be able to carry. And based on that, we can identify which roads are failing. And most of us who drive in rush hour or who drive on highways, certain highways every day, we don't need a sophisticated program to tell us that a road is failing. But for a transportation planner, you need to have a little bit more precision, and that's what these traffic counts give us. So we end up with a map that shows where our deficiencies are today. Then, based on that projections of revenue that we talked about, we can look at what we call a cost-affordable roadway plan. And the terminology may differ from jurisdiction to jurisdiction, but there is some revenue projection that goes out 20 or 30 or 40 years that says we think there's going to be this much resource, there'll be this much money for us to spend on transportation. And when you look at that amount of money, there is a way through a mathematical approach in these models to apply what you think that money will do in terms of fixing some of these problems. So you're going to project which one of these roads you're either going to enhance, or where you might even build some new pieces of the transportation network, and you're going to apply that money into the model. Then you're going to also project the future population, the future employment, and the future demand over that 20-year period, and you're going to rerun the model. So what you're looking at here is a 20-year future needs plan, and that future needs plan says if the population grows, if the employment grows, if we apply all of the resources over the next 20 years that we think we're going to have, here are the problems we're going to be facing in 20 years. And you can see this particular community didn't do so well. So this says to a transportation planner, maybe we need to find some other solutions. Maybe we need to start looking at not just the gas tax and our local revenues to fix those transportation problems. Maybe we ought to look at tolling and some other financial tools in the toolbox, because this as a future is really not acceptable. And that's the basic transportation, long-range transportation process. This is what it tends to look like. The models that we develop are network models. They break a community down into zones. We call them traffic analysis zones. And within each one of those zones, we can identify the population. That's both the amount of the population and the density of the population. And the reason population is important is that most of these areas are where we live, and we call them productions, because our basic trip in the morning and in the afternoon during rush hour, what we call peak hours, is really a journey to work. The journey to work drives most of the congestion that we have in the US. And to identify that journey to work, we need to understand where people are coming from and where they're driving to, and that's productions and attractions. Now, attractions are more than just the where you work. It's also where you shop, where you go out to eat, and where you go for entertainment. Those are also things that attract trips. So if we have a pretty good understanding of where our productions and attractions are, we can begin to create a mathematical model that identifies what the network looks like and how it works. Then, how do we do this? As you can see, the model, if we zoomed in on one of these areas, is broken up into what we call links and nodes. The links represent the various pieces of the highway network, and the nodes are either the major intersections or they are actually the major attractions. So it might be a shopping center, a large mall might be a node, a business park might be a node. The central business district is one large node in many cities. And being able to then mathematically move the productions and attractions, the trips that are generated daily onto this network of links and nodes allows us to create essentially a mathematical model of what's going on. We then have to code that model. We have to put in other variables that affect our trips. And part of that is the size of the roadway, the design of the roadway. So while that model looks like a link is just a line on a map, when we put the mathematics into the model, we have to actually put in how many lanes of traffic are on that link and what the design. Is it a limited access highway, which will carry more traffic, or is it a general service highway, which will carry much less traffic? And then we apply other variable factors. We call them K, D, and T factors. And while I'm not trying to make you experts in transportation planning, these are really important because these factors are the assumptions that we have to put into a model that actually can very much change the way the model works. The first one is our peak hour factor and a K factor. And then that tells us how when the peak hour is, when it begins and when it ends, and how much traffic, what percentage of traffic during the day falls into the peak hour. And then the D factor is directional distribution. Directional distribution is essentially how much traffic is going in one direction in the morning and in the reverse direction in the afternoon. And that's critical because some roadways have extremely high directional distribution. And high directional distribution will offer you an opportunity to provide a different kind of transportation solution than a roadway that's carrying traffic in both directions equally all day long. And then the T factor is also very important because trucks, and that's what the T factor stands for, the percentage of trucks on the roadway. The percentage of trucks is critical because a truck, especially, and we're talking about large trucks, they take up a much larger piece of the roadway than automobiles. A car will take up a certain amount of capacity of the road. A truck, because of its size and its lack of mobility related to a car, takes up about 2.5 times the amount of capacity of the roadway. So if you have a high percentage of trucks in your travel street, that road will actually carry less traffic. So I'll give you a perfect example. We have interstate highway percentages during the daytime that sometimes in urban areas run as high as 30% trucks. If you have a toll road and you only have 2 or 3% trucks using the toll road, you have much more capacity to sell, and you can impact congestion much more with that lower amount of trucks. So having a T factor tells you what the demand is in that particular area, certainly in a corridor, and how you might address it with a solution. This is what a directional distribution looks like when you graph it. It also shows you the peak hour characteristics. And what you're looking at here is very typical of what we see in an urban commuter roadway, specifically a toll road. You'll see a morning peak in one direction and an afternoon peak in the other direction, right around what people normally call rush hour. In the middle of the day, there's not a huge bump in traffic. And then over the period of time, you'll see that the directional distribution in this particular case says we have the ability maybe to come up with a solution that addresses this need to provide transportation in one direction only at one time of the day. If you look at an interstate's pattern, you'll see that those peaks are probably a little bit lower, and that there's a much bigger bump in the middle of the day around lunch hour. And some interstates, that peak goes up and stays there all day long. So it's just one of the kind of charts that we use as transportation planners to better understand what's going on. So then, okay, we have this wonderful mathematical model. We've put in all these variables. How do we actually get this model to tell us something that's worthwhile? That's what we call a calibration and validation process. Because we have such good information about the current amount of traffic on the roadways, we can build a model, we can load all of these variables into the model, and then we can run the model for the current population and employment. And when we do that, we can then validate that model. We can look at the output of the model and compare it to what we know is an actual fact. Here's the traffic today. We've built this model. We've loaded our population and employment. We've loaded all of the variables, the K, T, and D factors. And now we run the model and we compare it to the existing traffic conditions. And if we're within 1 or 2 percentage points in either direction, we know that we have really built a very successful model. If we are outside of those parameters, then we have to go back in and calibrate the model and rerun it until we can validate the accuracy of the model. Then we're in position of loading our future assumptions. We can look at projections of population and employment into the future. We can look at how much we think we can build and what we don't think is going to get built into the future. We'll put in the future system improvements, and then we're going to rerun the model for 20 years down the road, and that output is going to give us what the average daily traffic demand is on all of these links, what the level of service is going to be on these links, and where we really need to spend our future dollars. So that's how the long-range transportation planning process works. When we do that, the last term I used, level of service, it's one of the ways that we look as transportation planners to determine how well a road is working. And this is really a simplified chart that transportation planners and the general public, anyone working outside of transportation, can still easily understand. Level of service, or LOS, is calculated between levels of service A and F. And it's a fairly simple chart that A is the best level of service that there is, complete free flow, no congestion, and it has a volume over capacity ratio of 0 or no more than 60%. Now, volume over capacity tells us how well a road is working. If a road has a certain capacity and you're operating at only 60% of its volume, you'll have a free flow condition. So V over C becomes a telltale factor. It's one of the things we measure to determine how well a road is working. And we look at that coming out of our future model to also tell us how well or how badly a road is failing. As you can see, B is very light congestion. So if we're at 70% of what the capacity of the highway, we're still going to be operating very, very well. And even at the C level, at 80% of capacity, and typically we don't design our roads and we don't build them for level of service A. There isn't enough money and resources to do that. We usually target on a 20 or 30-year projection for a new roadway to operate at level of service C. We'd like it to operate at no more than 80% of its capacity over its useful life. And we call that the functional life of a highway. It's not the structural life. You're going to be out there repaving it every, I don't know what, 5 to 10 years, depending upon how much traffic. So it's the functional use of that facility that we care about as planners. As you can see, when we get down into the D and E range, we're starting to get into really heavy congestion. And E, at severe congestion, that says we are at capacity. We're slowing down. We've gotten to stop and go, what we call bumper to bumper, but the traffic is still moving at level of service E. When we get to F, we've basically stopped. And it's stop and then go, and then stop and then go. So it's not bumper to bumper movement, it's bumper to bumper stop and go. Level of service F tells us that that is the most severe problem. And those are the ones that we are generally focused on when we're applying our resources. So level of service is really the telltale measurement that we use to help us figure out what the future should be. And it is what we use when we start looking at specific projects, and we call them corridors. Corridor planning, again, is also a 20-year process, but it's where we start looking at developing, finally, concept plans. We're starting to look at engineering and environmental feasibility, and we're doing operational analysis. And this is where LOS really plays a role. So when we move from the long-range transportation planning process down to corridor planning, we're now looking at much more specifics. We've already identified that a corridor has a problem. It fails in our long-range plan. We now need to come up with some ideas about how to fix that problem. We call them concept plans. Environmental issues and engineering issues is a feasibility process at this stage. What we're looking for are serious problems. We call them showstoppers. Is there anything out there that we really need to be aware of that would cause us a problem? And maybe this means we don't look at this corridor for our solution. Maybe we find a solution somewhere else for this problem. So maybe we go around this area as opposed to going through it with our improvement. And then, of course, we continue to use the model, the long-range model, but we only use it within a small area. We're starting to look at a project and the operational analysis. This takes us to really toll planning feasibility.
Right.
And that's a financial process, right, Tom?
Yeah, and then we've identified the corridor at this point. Now we're looking for how we're going to pay for those improvements to that corridor, right? So part of the toll planning process begins here once we know we have a good corridor. So we look at those, as Marty talked about, we've looked at the project justification, we've looked at all the background details. Now we come in and say, well, Are there any other locations available for this corridor that could lower the cost, reduce environmental impact, reduce public issues? We look at those different corridors, as Marty mentioned, to try to find the best, most feasible one. And then we look at, is this really a good transportation project? Because if it's not a solid transportation project, as Marty mentioned earlier, it's not going to be a toll project. It has to be a really solid transportation need. And usually some of the worst or most difficult projects to build, elevate, and have higher costs, and therefore they ultimately become toll facility projects because it takes too long to accumulate the gas tax money to make that project really viable. And you want to address those as quickly as you can, those really critical projects. So now we start talking about the cost of these projects and how do we get there. We looked at different costs of the design costs, the right-of-way costs. Is it in a heavy urban district, a commercial district, a residential district? How much is it going to cost to acquire the land and then build the road, and the construction cost? Are we working on revitalizing an existing corridor, or are we in a greenfield situation where we're building a new corridor where we don't have to maintain traffic? Big difference in costs and construction schedules to do those two different types. And then we start looking at some gross toll revenue. What would be the best side, optimal side of toll revenue that this corridor could produce? And sometimes different corridors end up in slightly different revenues. And that all leads into this initial project feasibility effort where we determine, is this project feasible as a transportation project, number one, but also as a toll project? Will the costs be less than the ultimate revenues to pay back for the borrowing bonds that have to typically be used to build these projects? So that's where we get into the feasibility aspect.
Tom, throughout this, and it's something you mentioned to me before we started today, and I don't want to leave it out. Throughout this long-range transportation planning process, the corridor process, all of this feasibility analysis, there is a public participation element. You can't do this kind of planning in a vacuum. You have to have input from the public, and that input often comes through the MPO organization. But when you get down to corridor planning and specific project planning, you really have to do an outreach. You have to go to the public and show them what these concepts look like and try and get their support, because there is so much competition for resources that what we find in transportation planning is that it often turns out to be as much a political process as it does a engineering and financial feasibility process. So getting public support for a project sometimes is as important as all of these other activities.
And that's a good lead-in for talking about the environmental process of how these projects come together. And so the Council of Environmental Quality was the forebearer of a lot of the modern day environmental processes that these projects have to go through, which includes the NEPA, which is the National Environmental Policy Act, which really tells us how we have to address environmental concerns as we plan these projects.
You know, back in the 70s, late 70s, when I started my transportation planning career, we were doing environmental impact statements under NEPA at that time. An environmental impact statement looked like about the size of a comic book. It was a pretty thin document. I was really at the forefront of implementing the NEPA process. Today, environmental studies are extremely involved. They go into all kinds of very specific activities. Nixon's, one of his first executive orders was the protection of wetlands. And I know we don't think of him in this regard, but he is one of the first presidents who had an environmental conscience. When you look at NEPA and the federal environmental study process, what you see today also is that most states have adopted an environmental impact process that looks very similar. In fact, The only differences sometimes between the federal process and a state environmental impact process is who reviews the documents. So in the federal process, you often will end up with multiple federal agencies involved in looking at the results of your environmental study. It's one of the reasons that a federal study takes much longer and often is much more expensive because you have a lot more players involved. The state environmental impact process or the federal process still includes these four components. It has now hard preliminary engineering. We are beyond the concept stage. We're at the point where the engineering is much more specific to identify that potential right-of-way acquisition that you had mentioned earlier. The environmental impact analysis is also very specific. We're now measuring the potential impacts based on formulas and scales that have been developed at the federal level and approved both at the federal and state levels. Our public involvement is now formally organized. It goes through a step-by-step process all the way through a public hearing process at the end where these decisions can be validated. And then the cost estimates are also much more specific. When we do corridor analysis, our cost estimates are what we call order of magnitude estimates. But now, because we have preliminary engineering, we are now refining our cost estimates to get to the point where they are much closer to reality than those order of magnitude estimates done at the corridor level. We're also looking at the needs and project justification. And this is something that occurs throughout. Every time we go through a step in a study process, it always comes back to what is the need for the project, what's the justification, and when it's tolling, that's even a more specific look. We develop conceptual alternatives at this stage, so the preliminary engineering is not just to look at one solution. The idea in an environmental study process is to look at a range of alternatives, and those alternatives will include not just the construction of a major facility, it will also look at other enhancements that might meet the requirements, but not include widening the highway. So intersection improvements, other improvements on parallel facilities will be looked at in a corridor. Can we accommodate this demand by rerouting it into another area? And how does transit play into this? Could we address this demand by improving the public transit in a corridor? So there's a number of alternatives that we will look at, and then we boil it down to a set of final alternatives, and those final alternatives will go through a much more specific construction cost activity. We're going to look at a final environmental impact analysis, and then we're going to eventually carry it through our public involvement. Usually it means a public hearing, and a final documentation that's going to be sent out to a wide range of agencies and organizations for them to review and provide comments on. So it is a very formalized, very step-by-step process that we go through. It's not a bunch of people sitting in a back room deciding what to do. It's a very open process, very step-by-step, and it leads us to what we call a record of decision. Once we get a sign-off on the documents at the federal level, or if it's just a state document, we call that acceptance of the final alternative a record of decision. And in the tolling business, we need that record of decision for us to take our next step. Because again, we're part of the tolling industry and the tolling business, and toll agencies are part of the overall transportation planning that occurs within states. And that really carries us to what our role is in tolling that is one additional step. It's the step beyond the record of decision. A ROD, or a record of decision, is what a DOT needs to build a new road. We need to go one step further in the tolling business. We have to go through a very specific financial feasibility process that involves revenue projections, the costs, and in fact, we'll do another refinement of costs that now includes the operations and maintenance, the long-term operations and maintenance of the roadway. And we'll often look out a good 20 to 30 years because the bonding for a toll project is likely to be 30 years. We want to understand what the O&M costs are for that 30-year period. We're then going to go through a feasibility analysis, and we're going to carry this information to the bond market. We want our partners out there in the financial world to give us feedback. So we go out and we present this information, and we're looking for comments back. Before we go out and try and sell bonds, we want feedback from the financial industry and from the bond rating agencies. We want them to give us some understanding of the acceptability of this project before we go out and try and sell bonds. The investment grade studies, and Tom, I know you're very familiar with what we go through on the investment grade study process to get us to market.
Yeah, this is a very detailed analysis where consultants that specialize in this are really staking their reputation on the accuracy of their crystal ball and the projection of their revenues. And a lot of details come in here about the history of a certain region and their toll use. Have they never had tolls before in that region, or are they familiar with them? How acceptable or how accepting will the public be to that facility as a toll road? And we look at a lot of the forecasts of that market. Generally, how's the economic forecast of that market? Is it going to make a good toll project to be able to support those bonds over time? Marty, as you mentioned, all those factors, those K and D and truck factors, those all are critical in determining how much revenue is going to come in from those different types of users of the facility. And then what is the toll rate structure going to be? How do we plan that? Is it going to be indexed toll rates, as we've talked about in other segments, where the toll is going to go up each year to ensure the investment is going to be able to pay for itself? And we start looking at some of those detailed costs and when tolls would increase to be able to pay for those bonds over that 30-year time period. And then we consider what's a ramp up of how quickly the traffic is going to come to the toll facility. Is it going to ramp up, meaning it's going to meet 50% of its annual projections by the 3rd year or the 4th year or the 5th year? And how long does it take customers to get acclimated and see the value of that toll road? And that's all unique to the toll industry, because those types of analyses, as you mentioned, are not done on typical other non-tolled transportation networks.
When we get to the investment grade study, this is serious business. The toll agency basically has made a decision to move forward with the project. They're committed quite a bit of funding. These studies generally take about 6 months. They're pretty expensive. They have to go in front of Wall Street, and they will be heavily scrutinized by Wall Street and by underwriting companies. This is a process that is got to convince a wide range of people that this project is feasible and that the bonds can be repaid. And of course, where we get to at the very end is that we want acceptance by Wall Street, acceptance by the underwriters who will carry this project out to the bond market. And because these are tax-free bonds, and because the toll industry has such an incredibly good reputation for paying these bonds, typically they sell out in a day or two. So today we've had an opportunity to take a look at all of the components of transportation planning and how the toll industry fits in to the transportation planning process. I know this has been a little more of an academic discussion of that process, maybe a little bit deeper dive than what we've been doing on some of our other Toll 101 segments, but I hope everyone has gotten some value out of it. My name is Marty,
And I'm Tom.
and I hope you've enjoyed this segment of Toll 101. This program is made possible through funding provided by Aegis Projects, Inc., and with the additional cooperation of Atkins, Valencia College in Orlando, Florida, and Patterson-Bach Communications.